When it comes to fire, the most common color is probably orange or red, and this is usually from burning something like wood. What I've always found interesting, though, was how many other colors are possible, and it can really depend on what's burning. For example, if I add a solution of boric acid and methanol and light it on fire, I get a really nice green color. I can also throw some aluminum into an acidic copper solution and get a blue flame. What I think is even cooler, though, is what happens when I burn nitromethane. It actually doesn't burn on its own, and I have to give it a boost with some methanol. Now when I try it, I get a flame that has almost no color. There is a slight hint of yellow, but besides that, it almost looks like it's in black and white. In my opinion, it kind of looks fake, and I think this is better than anything with color. What I have here just looks like a generic yellow powder, but I think it's pretty cool. If I add it to some water, it all floats on top, which isn't too interesting. If I put my fingers in it, though, it has a really weird effect. This is happening because all of this powder, which is something called lycopodium, is strongly hydrophobic. It really doesn't like mixing with water, and instead, it just forms a weird, goopy-looking layer around my fingers. What I think is interesting, though, is that when I take my fingers out, they're still completely dry. Now, something else that I want to try is burning it, and on its own, not very much happens. So instead, I've added a bunch of it to a plastic squirt bottle, and I've taped a lighter to it. This way, it can be sprayed out as a dust and mixed with air, and it's definitely a lot better. So I've decided to do one of my favorite reactions, and the first thing I need is some sulfur. I'll just add about 20 grams to a little container. On top of this, I also need to add some powdered iron metal, and I measured out about 35 grams. This mixture can be a bit unstable, and stirring it normally can sometimes cause it to go off. So instead, I'll just carefully shake it around until it looks evenly mixed. It was eventually looking pretty good, so I dumped it all out, and I spread it out as evenly as possible. At this point, it's basically ready, and I just have to light it on fire. The classic way to do this is by touching it with a hot glass rod, but I apparently didn't heat it up enough, and it failed. So this time, I made sure to heat it until it was red hot, and on the verge of melting. It almost immediately liquefies the sulfur, which then reacts with the iron, and this generates a lot of heat. It's enough to keep the reaction going, and it goes until it all burns. When it's done, and after it's cooled down, I'm left with a large chunk of iron sulfide, which I'm sure I'll find something to do with. For this video, I'm just going to be doing something that I find fun, and all I need is some ammonium dichromate. Now, I just need to pour some into a dish, and light it on fire. It's sometimes a bit hard to get started, but it's eventually able to keep going on its own. What's happening here is a decomposition reaction where the ammonium dichromate is chemically falling apart. As it does this, it turns into green chromium oxide, and it produces a bunch of nitrogen gas and water vapor. At some point, it kind of starts looking like a little volcano, and it also lets off a lot of heat. It then keeps going like this until all of the ammonium dichromate has reacted. It eventually finished, and I now have a super puffy pile of chromium oxide, which isn't very useful. What's kind of fun, though, is to take a small amount of it and heat it using a blowtorch. Then, if I drop it into a flask full of ammonia gas, it makes a bunch of sparks, which kind of look like fireflies.